Welcome to The Explainer. Today, we're going to break down a really fundamental concept in computer science, something that's quietly working behind the scenes in a ton of the apps you use every single day, the linked list. Okay, let's kick things off with a frustration that, every programmer knows all too well. You've got this perfectly good list of items, an array, but the second you need to stick something new in the middle or pull something out, everything just grinds to a halt. So why is that so clunky? Well, it all comes down to how arrays actually store data. They keep everything in one continuous block of memory. Now, that's awesome for finding things fast, but if you want to change the sequence, you literally have to shift every single item that comes after it. It's a massive, time-consuming reshuffle. So you can probably guess, right? This exact problem is why a much more elegant solution was created. A data structure designed from the ground up for one thing: flexibility. And that solution is the linked list. So let's dive right in. It totally rethinks how we store a sequence of items, and it does it by trading that rigid memory for some incredible flexibility. So what is a linked list really? Well, unlike an array, a linked list is basically a chain of individual items we call nodes, and each node holds just two things: your data and a pointer, which is really just a link to the next node in the chain. This is such a great way to think about it. Imagine each train carriage, that's your node, can be anywhere in the train yard, that's your computer's memory. It really doesn't matter, as long as it's properly coupled to the next one. And this means you can easily slot in a new carriage or remove one, just by changing a couple of those links. No big reshuffle. Okay, so this is absolutely crucial to understand. There's no single best data structure. It's all about picking the right tool for the job. So let's put arrays and linked lists head to head and see where they shine. This chart just paints such a clear picture. You see, arrays store data side by side, which gives them that super fast random access, meaning you can jump to any item instantly. But linked lists, they're the champions of efficient insertion and deletion because their data can be anywhere. The trade-off? You have to access items sequentially, following the chain from the very beginning. But it doesn't stop there. The basic idea of a linked list is so powerful that it's been adapted into a few different flavors, each one designed to solve different kinds of problems. So the three main types you're going to run into are single, doubly, and circular. A singly linked list is just a simple one-way street, perfect when you only need to move forward. But a doubly linked list, that's a two-way street. Each node knows about the next one and the previous one, which gives you the power to go forwards and backwards. And then you have the circular list, which is just a big loop where the last element points right back to the start. Super useful for tasks that need to cycle over and over again. And look, this is not just some abstract computer science theory, okay? You are literally interacting with the logic of linked lists in the software you use every single day, and you probably don't even realize it. Remember that doubly linked list we just talked about? The two-way street? Well, that is exactly how your web browser's back and forward buttons work. When you're listening to a music playlist, hitting next or previous, that's pure linked list traversal. And that life-saving undo/redo function in your favorite app? Yep, that's often a linked list, just managing the history of all your actions. So, how does this translate into your own code? Well, getting your head around this one structure, it unlocks the ability to solve this massive range of programming problems, from the really straightforward to the incredibly complex. This quote from our source, Geeks for Geeks, just nails it. It perfectly summarizes the core value here. When your main concern is adding and removing things on the fly, the linked list is often your best friend. And that's the thing. Once you really get this concept, it's like a gateway opens up. It lets you tackle a whole spectrum of coding challenges, from easy tasks like reversing a list, all the way up to hard problems like building a sophisticated caching system from scratch. So the next time you hit undo, or you skip to the next track on your playlist, or you click that back button in your browser, you'll know. You'll know about the elegant chain of logic that's working hard behind the scenes. It's just a powerful reminder of how these simple, fundamental ideas can be linked together to build the amazing software we rely on every single day.